Okay, so let's work out this question together. What they want us to do in number one is to come up with the input-output matrices. Input-output matrices. Remember how they look like. Total output should be equal to who? Total output should be equal to who? The total output, ladies and gentlemen, the total output should always be equal to the intermediate demand, intermediate demand plus final demand. For your definition, remember at times they ask you to define these things. Intermediate demand is that need, internal need. Intermediate demand represents that portion of output which will be consumed by the sectors themselves for further production. If, for example, you are a huge farmer in Trans Nzoia, and for example, you have harvested, say, 100 bags of beans. So when you produce these 100 bags of beans, for sure, when you'll be selling, you can't sell 100 bags of beans here. No, you must retain some number of bags. Say you could retain, like, say, 10. Why are you retaining these 10? You're retaining these 10 to use them as seeds to plant them. So the 10 then will be the demand from within, intermediate demand from ourselves as sectors that we retain and consume for further what here? Productivity. And then if you recall, final demand is now what goes out there for consumption. Now, final demand is that portion of output which goes to third parties for consumption, which goes to third parties for so in short, whatever we produce from these sectors will always go to two places. Number one, we shall retain something internally. Whatever we retain internally is what is called intermediate demand. And then, of course, we shall be having something out there, which will go out there, called what here? Final demand. And then if you recall very well, the total output here is what we shall be calling X. Intermediate demand is what we shall be calling what here? We take the technical coefficients times this X plus final demand, which is normally designated as D. So in our case here, we have got three sectors. We have X1, X2, X3. X1, X2, X3. And then they have given us equations here. Which equations are these? They have given us equations here. Which equations are these? We have 0.3x1. We have 0.3x1 plus 0.3x2, 0.3x2, 0.3x2 plus 0.2x3 plus 0.2x3 plus D1. And then go to equation number 2. Equation number 2, we have 0.1x1 plus 0.2x2 plus 0.2x2 plus 0.3x3 plus 0.3x3 plus D2. And then we have x3. X3 is 0.2x1, 0.2x1 plus 0.1x2 plus 0.4x3 plus D3. So now, ladies and gentlemen, when they tell you to come up with the input-output, actually the right thing to say there is input-output matrices. They need us to have this matrix for this A, and then we have D, like that. So A is the technical coefficients matrix. So A is the technical coefficients matrix. So A is the technical coefficients matrix, which you can see here. The inputs, the outputs, which are converted to inputs. That is why we normally call these ones the input ratios. They're also known as input what here? Input ratios. They're also known as input ratios. So if that is the case, then our A will be equal to who? Our A will be equal to 0.3. We simply take these numbers. 0.3, 0.2, Then we have 0.1, 0.2, and 0.3. And then lastly, we have 0.2, 0.1, and a 0.4 like that. That is our A. And then now once you give me that, then I will be able to give you the input output matrices. I have some big space here. I'll be able to give you the input output matrices. There are three. So we have the first one, which is x1, x2, x3. Put it inside the brackets like that. I'm following this. Equals A is here, 0.3, 0.3, 0.2, 0.1, 0.2, 0.3, 0.2, 0.1, 0.4. Like that. I'm following this. X again. So x1, x2, x3. Close brackets like that. Plus, I'm following this. D, we have D1, D2, D3, like that. That is what was expected of us in number one. It's an old question. There are very few students who could get this question correctly. They wanted us to give them input-output matrices. Input-output matrices. So we want to know whether you've been able to copy up to there. Have you been able to copy up to there? Have you been able to copy up to there? If you've been able to copy up to there, please give me a thumbs up. Tell me, yes, we have done that. Yes, we have done that. Yeah, thank you very much. Now look at number two. Look at number two. Look at number two of this question. Number two of this question, they want me to give them the equilibrium levels of output for the three sectors, given that D1, D2, and D3 are 50, 30, and 60 million. 50, 30, and 60 million. Great. So in short, they want me to predict the outputs. How do we predict the outputs? How do we predict the outputs? To predict the output is quite simple for us. It's quite simple for us. How do we predict this output? To predict the output, there are two ways that I could make use of, and I'm going to use the two of them. So prediction of output. Prediction of output. So in this case here, I will use the Leontief's. I'll use the Leontief's inverse matrix. Leontief's inverse matrix. I would want to see whether there is any student who will be at a position of remembering how we were writing the Leontief's inverse matrix. The Leontief's inverse model. Is there anybody who can remember that equation really? Anybody who can be at a position of remembering that equation? Xavier has remembered one component, but not that's not the equation. That is what we call identity matrix, Xavier. But there is a very important matrix that we need here. There is a very important, not matrix, but equation that we need here. Somebody, not that one. Somebody, there is an equation that we need here. There's an equation that we need here. Is there anybody who will be able to provide that equation to us? Is there anybody who can provide that equation to us? Yes. Yes. Thank you very much. Well, they have told me, Florence, no. This is the Leontief's. Leontief's, this is the one that I'm looking for. That our x should be equal to I minus A inverse multiplied by what here? Somebody multiplied by final demand. Yes. I know what you guys are talking about. You guys are talking about this I. This I stands for identity matrix. And because our A is a 3 by 3, because our A is a 3 by 3, then the identity has to be a 3 by 3 matrix. 3 rows, 3 columns. So as somebody has told me there, it's going to be like this: 1, 0, 0, 0, 1, 0, 0, 0, 1, like that. So up to there, remember, if it was a 2 by 2, this is how it would have looked like: 1, 0, 2 columns, 0, 1. Right? So first of all, I would want somebody to show me a thumbs up if we are together, or a thumbs down. There's a place for a thumbs down if you're not together. Up to there, identity matrix. Are we together? Are we together up to there? Are we together up to there? Are we together? Are we together up to there? You can say Y for yes if you're not able to see the thumbs up, thumbs down. So Deborah says yes. At least she knows. Kiama, yes. Thank you very much. Thank you very much. Now, ladies and gentlemen, the moment you have this identity, then what we need to do is to come here. What we need to do is to come here and take care of the bracket. The bracket tells me to say I minus A first. So the I here is 1, 0, 0, 0, 1, 0. Then we have 0, 0, 1 minus my A matrix. If you remember, the A matrix is this one. The A matrix we have here as 0.3, 0.3, 0.2. We have 0.1, 0.2, 0.3. We have 0.2, 0.1, 0.4, like that. Okay, I would want to do something very interesting here, very interesting. So I expect you guys to move with speed, to move with speed. You move with speed, you move with speed, and they give me these figures, like now 1 minus 0.3. So my I minus A. I minus A, we have here I minus A. So 1 minus 0.3, that gives me 0.7. Next, corresponding, this will give me minus 0.3. This gives me minus 0.2, minus 0.2. This gives me minus 0.1, minus 0.1. This gives me 0.8, 0.8. This gives me minus 0.3. So 0 minus 0.2 gives me minus 0.2. This gives me minus 0.1. This gives me 0.6, like that. So we have I minus A. But don't forget the equation kindly. Remember, there is something that we are after. There is something that we are after. There is something that we are after. If you remember this Leontief's thing, what we want to do, the Leontief's thing, we have our X being equal to I minus A inverse times D. So this I minus A inverse is what we want. And to inverse this matrix, the matrix happens to be a 3 by 3 matrix. This happens to be a 3 by 3 matrix. Is there anybody who can remember those 4 basic steps of getting an inverse of a 3 by 3? Of getting an inverse of a 3 by 3 matrix? Anybody who is able to remember those 4 basic steps? I'm waiting. Number 1, Chebi tells me determinant. Thank you very much. Determinant. Number 2, minor elements. Minor elements. I'm surprised there's only one student who is able to remember this. So number 1, Chebi tells me it is ascertainment of the determinant. Number 2, come and give us the minor elements. Number 3, give us who. Number 3, cofactors. Thank you very much. Cofactors. Number 4, lastly, inversion. Inverse definition. Number 4, lastly, is inverse definition. Thank you very much. Now, I would want you to do me a favor. This is the matrix whose inverse I want. If it is the matrix whose inverse I want to see whether there is anybody who will be able to remember how we were computing the determinant. How do we get the determinant? 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 Is there anybody who is able to remember the formula? Determinant equals who? Determinant equals who? Yeah, it's PPD minus PSD. It is product of primary diagonal minus product of secondary diagonal. Product of primary diagonal minus product of secondary diagonal. Product of primary diagonal minus product of who? Secondary diagonal. Thank you. So then I would want a good student to tell me the way forward, because I would really want to get the determinant of this. I would want to get the determinant of this. So to get the determinant of this I minus A, determinant of I minus A, this is what I will do. Determinant of I minus A is 0.7 minus 0.1 minus 0.2 minus 0.3, 0.8 minus 0.1 minus 0.2 minus 0.3, 0.6, like that. So remember now, to get the determinant, there are two ways. You could come and very fast here, duplicate. Do you remember the concept of duplicating the first two columns? You duplicate the first two columns. You duplicate the first two columns. You duplicate the first two columns. You duplicate the first two columns like that by the side of the major matrix. And then remember, the primary diagonal is the one that runs from the first element of the matrix, this one, cutting across 3. This one like that, cutting across 3. Those 3 parallel ones, those are primary diagonals. So could you then kindly go ahead and give us the product of the primary diagonal? So product of the primary diagonal, we have 0.7 times 0.8 times 0.6, that's the first multiplication, plus the second diagonal, which is minus 0.3 times minus 0.3 times minus 0.2, plus the third one, which is minus 0.2 times minus 0.1 times minus 0.1. So is there somebody who can give me the PPD? PPD stands for product of primary diagonal. PPD stands for primary, product of primary diagonal. Is there anybody who can give me that figure? Is there anybody who can give me that figure? Is there anybody who can give me that figure? Please move with speed. If you're not able to follow, you also let me know that you're not able to follow for me to know what I should do. So it's all about duplicating the first two columns. Don't ask me why at the moment. If you want to know why we are duplicating only 2 and not 3, I would want to answer that question on 15th of October. After you guys have even passed CPA section 4. After you have passed CPA section 4. Great. So what do we have there? What do we have? Somebody give me an answer for PPD, product of primary diagonal. What do we have? I'm waiting for your beautiful answers. According to Lillian, she's getting 0.352. Is there someone else who is able to get this 0.352? Can someone else confirm 0.352? They have given us different figures. We have Moses saying 0.316. Please take my answers, my figures here with some pinch of some salt. I could have missed out on a negative or something, right? Dorcas Mew is confirming 0.316. So my friend who gave me this very fast answer, confirm again. It's supposed to be 0.316. Thank you very much. Confirm again. And then now we go to the secondary diagonal. Product of secondary diagonal. Are you able to see the secondary? There are 3 of them. So we have the first one there, we have the second one there, we have the third one there. I would want you to go ahead and multiply them, and then you give me the product of the secondary diagonal yourselves. Give me the product of the secondary diagonal yourselves. So all of us, are we able to get that 0.071? Are we able to get that 0.071? All of us, are we able to get that 0.071? All of us are able to get that 0.071. Because what they have done for PSD, they have taken this minus 0.2 times 0.8 times minus 0.2 plus minus 0.1 times minus 0.3 times 0.7 positive plus the three of them. 0.6 times 0.1 negative times 0.3 negative, which in this case here, most of them are telling me will give us 0.071. Thank you very much, 0.071. So, and therefore, the determinant, remember, it's product. Product means you're multiplying. Product of primary diagonal minus product of secondary diagonal. So product of primary is 0.316 minus product of secondary, which is 0.071. So could you kindly give me this figure? Kindly give me this figure, kindly give me this figure. Kindly give me this figure, 0.316 vis-a-vis 0.071 when you subtract. So somebody tells me it is 0.245 like that. Thank you very much. So you've been able to get the determinant. So after getting the determinant, what will be the second step, my friends? My friends, could you kindly guide me? After getting the determinant, what will be our second step? in this question. Our second step will be to get the minor elements. Is there anybody here who is able to remember how we were computing minor elements? Is there anybody who can remember how we were computing minor elements? Minor elements, if you recall, this is the one we normally use, hide and seek. Hide and seek. That if you want, in this case here, if you want to get the minor element of this 0.7, you hide it row-wise and column-wise. You hide it row-wise and column-wise. And then you will be able to give us the minor. How do you get the minor? You simply give us the determinant of the left submatrix. So this left submatrix tunasema, unaona umecover this row-wise and column-wise. And then we are left with a submatrix which is uncovered. So this submatrix which is uncovered is the one you give us its determinant. Determinant is product of primary minus product of secondary. So this will be 0.8 times 0.6. Minus, always put brackets for secondary. Minus, if this is the primary, the secondary is there. So minus 0.1 times minus 0.3. So could you kindly give me the figure here for M? M will be equal to what, somebody? M will be equal to what? The first minor element. The first minor element. The first minor element. So anytime I hear over minor elements, always remember hide and who? Hide and seek. Always remember hide and seek. Always remember hide and seek. Always remember hide and seek. Hide and seek. So 0.45, thank you very much. 0.45. How about the minor element of the next number? The next number, which is this. There's no problem. If you want me to give you the minor element of this, it's very easy. What I'll do is to hide and seek. So I'll hide the row where the number is found in and the column. And then if I do so, I'll be left with the 4 figures which are unhidden. These 4 figures that are unhidden are the ones I'll use to get the minor of the hidden figure, right? Of the hidden figure. So in this particular case, the 4 figures that we have here, here we have, of course, I can see minus 0.1, this and this, times 0.6 minus, bracket always, if you forget brackets, you'll not get it right, minus 0.2 times minus 0.3. Could you kindly give me the second minor? Kindly give me the second minor element. Give me the second minor element. What are we getting there, somebody? It's only one student. I can't work with that. Must get from other students as well. Although I think Moses, that figure is correct. That figure must be 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 correct. Yes, Dorcas has confirmed it. It's minus 0.12. Now with your friend, of course, at home, right? Try to teach somebody, give me the minor elements of all the others. Give me the minor elements of all the others. So is there somebody who has been able to get the third one? Is there somebody who has been able to get the third one? Sam tells me the third one is 0.17, but I would want someone else to confirm this. Even Moses has been able to confirm the same. How about the fourth figure? The fourth figure. How about the fourth figure? Minus 0.16. Can somebody else confirm this figure of minus 0.16? Moses saying minus 0.2, so I have to go a little bit slow to be able to see who is telling us the truth. The fourth figure. Remember, when you cover one figure and you're using a pencil, when you want to move the next one, you must use your rubber very well. Rose is saying 0.2. Minus 0.2. So this number, what I'll do, I'll hide it that way, that way. When I hide it this way and this way, I'm able to picture out and tell you that straight away, the primary diagonal will be minus 0.3 and a 0.6 because I'm able to see. I've hidden this and that. And then I'll come and say minus, always open brackets for the secondary. If this is the primary, the secondary will be the other one. So we have minus 0.1 times minus 0.2. Could you kindly give us this answer? Confirm to us. What are we getting as the fourth figure? Minus 0.2 seems to be popular. Thank you very much. How about the fifth figure? The fifth figure will be positive. The fifth figure will be positive. The fifth figure will be positive. Let's see, 0.38. That has been confirmed by two people. That has been confirmed by two people. Please go to the sixth one. Please go to the sixth one. Yeah, when you tell me minus, I know the figures at the peripheries, center here must be negative. The center figures must always be negative. Like I know the next one will be positive. The next one will be positive. The next one, I'm so sure the next one will be positive. The next one, which is figure number 7. Figure number 7, according to Moses, should be 0.25. Lillian is getting totally a different figure, 0.07. Let me go a little bit slower on this because I can see very different figures. I can see very different figures. This 0.25 seemingly is the correct one. 0.25 seemingly is the correct one. Look at how I will do it myself. Because it is this, I'll hide that and that. And if I hide this and that, then I'm able to see the primaries which are left uncovered. It is 0.3 times minus 0.3, minus open brackets. So if this and this, then the secondary will be this. So 0.8 times minus 0.2. If you forget the brackets, you'll get it wrong. So can all of us confirm that this 0.25 is correct? Can all of us confirm that this 0.25 is correct? All of us, can we confirm that the 0.25 is correct? Yes. So please, the 8th one now, second last. The 8th one now, the second last. The 8th one, the second last. Minus 0.23. Minus 0.23. It has to be negative, yes. So go to the next one, the last one. The last one is 0.53. Thank you very much. 0.53, the last one. Because for the last one, I'll have to hide the number row-wise, column-wise. So I'll be left here with 0.7 and 0.8. Multiply them. minus open brackets for the 2. Great. So having gotten that, the next step will be for us to give them the cofactors. Remember, cofactors, basically, we don't want cofactor values here to be having any negative. Cofactors, we can never have cofactors with negatives. And that is why they came up with this diamond rule, touching only the numbers with what here? Negatives. Negatives like that. Touching the central figures of the external rows and columns. And the rule is that those numbers must have their signs being what here? Changing. So ultimately, we'll have all the figures here being what here? Positives. So then the cofactors, we shall have 0.45, 0.12, 0.17. Then we have 0.2, 0.38. These ones are changing now, signs. 0.13. Then we have 0.25. We have 0.23. We have 0.53 being our cofactors. Right? Right? Now from there, ladies and gentlemen, come and define our inverse. So inverse definition. Inverse definition. So inverse definition. So our inverse definition. Inverse definition. So our inverse definition here will be I minus A inverse. I minus A inverse, it will be 1 over the determinant times cofactors. Cofactors done what here, somebody? Times cofactors transposed. It will be 1 over the determinant times cofactors transposed. So is there anybody who is able to remind us the determinant of this thing? Determinant of the question that we are doing here. Determinant of the question that we are doing here. Determinant, is there anybody who can remember the determinant? 0.245. 0.245 is what I've been given, 0.245 into, do we still remember the concept of transposition? Transposing a matrix like this means changing rows to become columns. So row number 1 becomes first column. So then this will be 0.45, this will be 0.12, this will be 0.17. So row 1 becomes column 1. And then now we have row 2 becoming column 2. So row 2, this will be 0.2, 0.38, and then we have 0.13. And then now we have row 3 becoming column 3. So then this will be 0.25, 0.23, 0.53, like that. So remember, it is rows becoming columns. Rows becoming columns. And once you have been able to get that, then ladies and gentlemen, the next thing for us here will now to come and use the Leontief's equation. So Leontief's equation, remember, we normally say Leontief's for prediction, Leontief's equation, we normally say our total output equals I minus A inverse multiplied by D, which will be equal to, what do we have this big thing? 1 over 0.245 into 0.45, 0.2, 0.25, 0.12, 0.38, 0.23, 0.17, 0.13, 0.53. And then now this one, we shall come and put the final demand figures out. The final demand figures now will be kept out there. Is there anybody who is able to see the final demand figures in this question that we are doing? Is there anybody who can see the final demand figures? Is there anybody who can see the final demand figures? The final demand figures that we have been given are here. The equilibrium levels of output for the three sectors, given that D1, D2, and D3 are 50, 30, and 60. So we have 50, 30, and 60. So we have 50, 30, and 60. So could you kindly then move ahead very fast and do the matrix multiplications for me? Please do the matrix multiplications for me. This is quite a technical subject, but I can see you've really tried to hang around, meaning that you're still following. So then this, first of all, we leave this out. Whenever we are multiplying two matrices, remember it is the concept of what you are Roman Catholic. A row multiplies a column. And how do we do it? First one's multiplied, plus second one's multiplied, plus third one's multiplied. You give us an answer. So first one's multiplied, plus second figure's multiplied, plus third figure's multiplied. You give us an answer. Give us an answer. So we have Roman Catholic. Row 1, column 1. Please make sure that you are not really having two left foot by hanging on one number alone. You'll get somebody saying 0.45 times 50 plus 0.45 times 30 plus 0.45 times. No. It is 0.45 times 50. First one's multiplied, plus second one's multiplied, plus third one's multiplied. Give me an answer. Somebody has not spoken to me at all. Somebody has not spoken to me at all. Please give me the answer. Chebi tells me it is 41. Chebi tells me it is 41, the first one. I'm here to get that answer from somebody else who is supposed to come and confirm this to us. We're supposed to come and confirm this to us. Is there anybody else who is able to get these figures? Anyone else who is able to get this figure 41? Please move with speed because I have another class. Moses says for 3.5, so I must get from a third student. TB, how comes they're getting different answers? And it's supposed to be 0.45 times 50 plus 0.2 times 30 plus 0.25 times 60. For 3.5 seems to be popular. Now from there, we target now row number 2. So this row 2 will multiply the first column. Row 2, first column. How do we do it? Very fast. First one's multiplied, plus second one's multiplied, plus third one's multiplied. Is there somebody who can give us that answer? First one is 0.12 by 50 plus 0.38 times 60 plus 0.23 times 60. So I'm being given by Tabitha Wanjiko 31.2, 31.2, 31.2, 31.2. Thank you very much. How about the last one? The third row by this column. The concept is pretty similar, the same. The concept is the same. First one's multiplied, plus second one's multiplied, plus third one's multiplied. You give us a figure. So Tabitha is confirming 43. They have differed a little bit. There's one giving us 44.2. This 44.2 has been repeated by someone else. 44.2. Thank you very much. Now, from ladies and gentlemen, I would expect you to use now distributive law and distribute this inside the scalars. Distribute this inside the bracket here to each number, So then what this will mean is that the final output, the output for X1, the output for X1, so X1 here, X1 there will be 43.5 over 0.245. X2 will be 31.2 over 0.245. X3 will be 44.2 over 0.245, which will end up giving us what figures in 2 decimal places? In 2 decimal places. In 2 decimal places, what figures are we going to get in 2 decimal places? In 2 decimal places, what figures shall we get? In terms of 2 decimal places, what figures shall we get? In terms of 2 decimal places, what figures shall we get? What figures shall we get? Who is that fast student who can give me these figures very fast? So the first one, 177.55, and that has been repeated by someone else. How about the second one? Thank you very much, TB. How about the second one? The second one, Lilian says 127.35. 127.35. Thank you very much. How about the third one? The third one is 180. 180.41. 180.41. 180.41. 180.41. So thank you very much. Let's keep on engaging on WhatsApp. Tomorrow is not QA. During the day tomorrow, it will be financial reporting in our revision bootcamp for 1 week. Is there any student who is doing financial reporting here?